Today we're going to learn about the addition rule and an introduction to two-way tables. General addition rule. For two events, theta 1 and theta 2, within a probability space, the probability of the union of theta 1 and theta 2 is calculated as follows. Probability of theta 1 union theta 2 equals the probability of theta 1 plus the probability of theta 2 minus the probability of the intersection of theta 1 and theta 2. But why would we need to subtract the intersection? Remember, probability of theta 1 includes all of theta 1. Probability of theta 2 includes all of theta 2. If you noticed, that means we've counted the intersection twice, which is why we need to subtract one intersection. Special case addition rule. If two events theta 1 and theta 2 are disjoint, then the addition rule reduces to the following. The probability of theta 1 union theta 2 is equal to the probability of theta 1 plus the probability of theta 2. Remember the example from 2.1, where we created a sample space and then we were asked for the union of theta 1 and theta 2. We ended up adding the pieces that we had calculated in our sample space in order to get the probability of the union, which was 0.88. Number 1, use the addition rule as another way to calculate the probability for the union. So the probability of theta 1 union theta 2 is equal to probability theta 1 plus probability of theta 2 minus the probability of the intersection. The probability of theta 1 is 0.74. The probability of theta 2 is 0.26, and the probability of the intersection is 0.12. This leaves us with 0.88. This formula is especially helpful to calculate probabilities without having to draw out a sample space. Number 2, there are 30 students in Mr. Cooper's class. 18 of them are boys and 12 of them are girls. Mr. Cooper chooses a student at random to take the attendance folder to the office. 4 of the boys have previously taken the folder to the office and 3 of the girls have previously taken it. Create a two-way table to display this data. The rows will represent one event and the columns will represent the other. Each event is split into its options, so we either have boys in the class or girls in the class. For the columns, we either have a student that has taken the folder or has not taken a folder. And for the bottom row and the right-hand column, we're going to add all the numbers up to get totals. Let's first fill in what we know about the table. First of all, there are 30 students in the class. There are 18 total boys, so 18 goes under boy total. 12 girls, so 12 goes under girl total. 4 boys have taken the folder, so that would be 4 under boy who's taken folder, and 3 under girl who's taken folder. The empty spaces we can fill by adding and subtracting. 4 plus what gives you 18? That would be 14. 4 plus 3 is 7. 3 plus what gives you 12? That would be 9. 14 plus 9 is 23. And then check that you did it correctly by adding up the row total and the column total to make sure it is truly 30, which I like to call the total. If Mr. Cooper randomly selects a student, what is the probability he selects a boy who previously took the folder? Make a new two-way table and fill in that probability. Then fill in the remaining cells with their respective probabilities. Include row and column totals. Those would be called marginal relative frequencies. The probabilities inside the table are called joint relative frequencies. So we'll recreate our two-way table from part A, but this time, instead of putting the amount of boys who have taken the folder in the box boys taken folder, we need to put the probability that a boy has taken the folder in this box. When making a two-way table to display probabilities, the total is going to be 1 because the probability of the entire sample space is 1, or 100%. That would be 30 out of 30 students. Instead of how many boys have taken the folder, we want to know the probability that a boy has taken the folder. So 4 out of the total, which is 30, which makes girls who have taken the folder a probability of 3 out of 30. Add those two together and you get 7 out of 30. Notice how every frequency just now has a denominator of 30 because theoretical probability is just desired outcomes divided by total outcomes. Use a calculator to find the decimal version of each fraction. Round or truncate to no less than 3 decimal places. You can always check by adding your row and column totals. The original question asked what is the probability he selects a boy who previously took the folder. That would be the probability of boy intersection taken folder, which is 4 out of 30. 0.133. If a student is chosen at random, what is the probability that the student is a girl or is a student that has taken the folder previously? This question is asking for the probability of a union, the probability of girl union taken folder. Using the addition rule, that would equal probability of girl plus probability of taken folder minus the probability of the intersection. The probability a student is a girl is 0.4 under girl total. The probability the student has taken the folder is 0.233 under taken folder total. And the intersection, one of our joint frequencies, is in the box intersected by girl and taken folder, so 0.1. The probability that the student is a girl or has taken the folder previously is 0.533. For Part D, go ahead and shade the cells in your table from Part B where a student has previously taken the folder. If a student previously took the folder, what is the probability that the student is a girl? This probability is slightly different because it adjusts the size of our sample space. Shading only the cells in the table for students that have taken the folder means we're focused on one piece of the sample space. Once we've diminished the sample space, the total number of possible outcomes diminishes greatly. We now only have 7 students to choose from, students who have taken the folder before. So that probability will be our denominator, the probability that someone took the folder, 0.233. But the specific intersection that will be our numerator is probability of girl who took the folder, which is 0.1. 0.1 divided by 0.233 is 0.428. The probability we found in Part D is called conditional probability and relies on changing the size of the sample space by focusing on one or another particular event. And that's addition rule and two-way tables.